I want to officially welcome you at this time to the Venn diagram. Venn diagrams are very helpful for thinking conceptually about regression and shared variance, explained variance, etc. And so here on this slide we have these lovely 3 circles. And the circles represent all of the variability in a given construct. So we have the variability in salary there is illustrated by the circle, and that's our DV that we're trying to predict. And then we have years since PhD is the first variable, the first predictor, and that is depicted by the one that has those little lines through it. And then the other predictor is the number of publications that a person has. And that's our second predictor, and again the circle represents all of the variability in that variable. So when the circles overlap, that means the extent to which the predictor shares variance with the other variable. So the overlapping parts indicate correlation or shared variance. So as we can see, both variables overlap with the DV to some extent. And in this Venn diagram, we can see that the predictors are assumed not to correlate with one another at all. So they don't overlap, the 2 predictors, but they just overlap separately with the DV. So this represents a very unrealistic scenario, and in fact, I haven't done the correlation between years since PhD and number of pubs, but I would say they're probably correlated at a healthy level, maybe 0.5 or 0.4. So I'll probably run that analysis with you in a second here when I do a screencast. But all that to say that this scenario with the Venn diagram is probably not an accurate depiction of reality. So, but it's instructive. It's helpful to see what that looks like if they were uncorrelated with each other, and also just to explain to you the Venn diagram. So we have A and B there. A just represents the overlap between x1 and y, and then B for x2 and y. So that's generally how I'll refer to predictors, by x1, x2, x3. That's just the notation, and then of course y is the DV. Now, I want to just let you know that there's like 3 different terms that mean the same thing. Again, it's always that way in our field, it seems like. But when we talk about variables being uncorrelated, we can also say that they're independent or orthogonal. So there are 3 ways to say that things are uncorrelated with each other or unrelated. Oh, I just made up a 4th. So we have unrelated, independent, uncorrelated, and orthogonal, and they all mean the same thing. So when you hear them at conferences, people may use one of those terms and assume that you know what they mean. So we joked in graduate school, I recall, that we need a thesaurus for our field, because there are just so many terms that mean the same exact thing. And anyway, it's quite interesting to try to socialize new folks into the field too. It makes for an interesting process, but we will make it through together. Every once in a while I'll hear a new term that I've never heard before that will be like a synonym for something that I am familiar with, but I just didn't know that it was called something else as well. So anyway, so we have no overlapping variability between the predictors depicted in this illustration, but we know that in real life they probably will come together and share variability, and that variability the shared part will also probably be correlated with our DV. So we're going to do some analyses that will show us how that works.